To characterize the pump, we started by finding the lowest intensity where the pump worked in the 10 table. A timer was started when the pump was turned on and was stopped again once the pump had pumped a certain volume of fluid. Each intensity was tested 3 times, and the means and standard deviation was computed for each intensity as seen on the graph. The purpose of the mathematical modeling is to calculate the initial concentration in the algae bucket needed to sustain the muscle feeding. On the right we can see that bucket B drops from 9,000 to 6,700 cells per milliliter over 15 minutes because of a constant 1.341 liters per hour per muscle filtration, and it gains about 52 cells per milliliter from algal growth. We solve the equation on the bottom left, yielding an initial algae bucket concentration of 3.08 times 10 to the power 5 cells per milliliter. And the left plot shows the concentrations as a function of time after an initial 120 milliliter transfer.
To set up the temperature control via the PID, we first determined the 3 parameters through trial and error. We then tested our PID control loop by cooling lukewarm water to a set point of 18 degrees. This plot shows the water temperature reaching and stabilizing at the set point.
To calibrate our OT sensor, we ran 6 different concentrations through the tubing shown on the left and measured the intensity when a red, a green, or a blue LED light was shown on the sample. This was because our sensor is an RGB and we wished to also test how the sensitivity of the final sample and of the sensor changed with each color.
In order to calibrate the OT sensor, we tested 2 separate models, one which involves a linear relationship between log I and C, and one that involves an exponential relationship between the two. The latter proved to be more accurate, having an overall smaller square loss across all colors. We then compared the square loss between the models corresponding to different color LEDs and concluded that the blue LED is the one that provides the highest accuracy.
Our system continuously collects and securely stores sensor data, including water temperature and algae concentration, but also pump speed and selector position in a backend database. The current system status and the system settings are always visible on the website, and settings can be easily adjusted directly through the web interface. In addition, all measurements are visualized in a graph, both in real time and over selectable time intervals, so that users can conveniently choose a specific time range and download the corresponding data as a CSV file for further analysis. As a backup, all data is also saved locally on the microcontroller in CSV format. This file can be manually exported in case of a server issue.
Upon scaling, our system would just require the increase in power demand of 2 components versus the increase in power demand of 3 components that the alternative system would experience. The venturi valve and the selector would simply increase the device in size, demanding more material and space. According to our computation, our single pump selector system would consume 46% less energy a day than the theoretical double pump system. We added the venturi valve to replace the air pump. However, as the current system has a large enough water surface area, the oxygen content is actually sufficient. We still believe that if the system is scaled up, if we would add more organisms or if the water surface changed, that the venturi valve could actually be very helpful.
We reused food delivery boxes and airline blankets to insulate the system and calculate the thermal resistance at 4.06 for the isolated bucket and 1.03 for the control, which means our isolated system is about 4 times more thermally resistant than the non-isolated one. These are the following things that we bought for our system. We ended up not using the aluminum foil in the freezer packs in our final design.
To make sure our system is safe, we soldered and encapsulated the thermistor wires to ensure their waterproofness and lengthening. Additionally, we handled all the electronics carefully and made sure that no water came in contact with them.